Hey guys, welcome to tonight's video, and we will be looking at hyperbolas today. So we're continuing on with the topics of conics. So what's a hyperbola? A hyperbola is defined by a collection of points where the difference of the distances from the 2 points is constant, and the 2 points that I'm talking about will be the foci. A focus and a focus equals foci. So just like an ellipse, a hyperbola has 2 focus points. And remember when we're doing parabolas, the focus is always inside. Same case here. Just a few definition terms that were, actually let me describe a little bit about that definition. So again, we're saying that a collection of points where the difference from, if I choose a point on right there, this is a hyperbola, I choose a point right there. So the distance from that point to the first focus compared to that point to the next focus. So if I get those distances D1 and D2 and I get the difference, it always has to be a constant no matter where I choose to put the point, either on this side or on this side. So again, it's that difference which is always constant. That translates right into the standard form of the equation of hyperbola. But first, let's look at some definitions. So the axis that contains those focus points and also contains the vertices is called the transverse axis. And then the alternate axis, which is perpendicular to the transverse axis, is called the conjugate axis. Another thing to look out for is that a hyperbola will have asymptotes. And then there's this kind of rectangle in here, which will be really important in helping us determine how to correctly draw the hyperbola. And another thing to point out is that the center is the midpoint of the transverse axis. So the center right there, that is the midpoint of the transverse axis. And we need to get rid of that. Sorry, the lighting went bad there. And another thing to remember is that there are 2 separate branches, but these are asymmetric. Okay, so now that we've looked at that, how does all that translate into the standard form? Well, again, like the standard form of the equation, again, like the definition gave us, it's that difference, that's the difference in the distances that's always constant. Thus, we see a difference in the standard form of the equation. And then we've got x minus h squared over a squared minus y minus k squared over b squared equals 1. Notice in this case, how, like, I might be curious, how do I know where the transverse axis goes? Is it always horizontal? In this picture, it's horizontal, which means like the parabola is drawn on the horizontal axis or parallel to the horizontal axis, depending on the position that it's at. How we determine that is by normally, so okay, if I look at the left side here, obviously I see one part's positive and then another part is negative, and they're combined using that negative. So whichever part is positive, like in this case, this part was positive, the part that contains the x variable was positive, that tells me that the hyperbola will be drawn parallel or along the x-axis, which is horizontal. And we'll look at another example whereby perhaps the positive part, contains the y variable. That means that the hyperbola will be drawn on the y-axis or parallel to the y-axis. That means that that will be a vertical hyperbola. And another thing to note, that in this formula, the a squared and the b squared, we never change where they are. No matter the term that's no matter the variable that's positive, either x or y, the a always comes first and the b comes second. So we never change those. And then looking at the focal length distance, this is what tells us, how the c is the distance from the center to the focus, a is the distance from the center to the vertex, and b will be the distance from the center to the to that one end of the conjugate axis. So what relates those three is the focal length formula, which is c squared equals a squared plus b squared. Now this is a little bit different from yesterday's video, which was the ellipse, but just note that this is a formula that goes together with the hyperbola. And then We'll also be looking at eccentricity, which is, again, how is it more oval or more stretched out? How much of those two characteristics the hyperbola is. And again, the formula is consistent as from last time with the ellipse, which means E equals C over A. Again, C describing the distance from the center of the focus, and A describing the center from the center to the vertex. And note, the vertex is a point on the hyperbola. So the vertex is that point right there on the hyperbola. And so it allows, well, this follows that E will be greater than 1, because notice that C in this case is larger than A, because C goes all the way out to the focus, and then A is just short. So a big number divided by a small number will end up giving us an eccentricity value that's greater than 1. So if E is large, the branches are nearly flat. Again, I'll repeat. If E is large, the branches are nearly flat. If E is close to 1, then the branches are more pointed. Okay? All right, so that was a lot of information. Let's see if we can use all that to apply into some examples here. So the first example we're given is this example right here, and the question we're told is graph this. Okay? So how do we start? So look at your notes, try this on your own, and then pause the video, just take as much time as you need, try it out, and then come back and we'll compare what you all get and how I solved it. So by now you should have solved that problem. So first thing that I asked myself is, where is the transverse axis? Okay, so I asked myself, which one was the positive one? Was it the x variable or the y variable? In this case, it was the x variable, which means the transverse axis is along or parallel to the x-axis, which means this will be a horizontal hyperbola. And then the next thing I asked myself, where is the center? Well, the center was at 3, -1, because I just grabbed that 3 from right there, and the -1 from whatever is from the k that's attached to the y. And then after that, I'm like, okay, let me start using the information that I know in order to graph. So I go ahead and I find 3, -1 as that point on the center. And then next I go to my focus length formula, which gives me the provisions that c squared equals a squared plus b squared. And at this point, I do know what a squared and b squared is, because I was given the standard formula equation of hyperbola, which means a squared is 4 and b squared is 25. Therefore, I substituted those two, which gave me c squared equals 29. And this is important because it'll end up giving me the distance c, which is the distance from the center to the focus. So once I have those, I can just count the distance, plot, and then just draw them in there. And do I know where the vertex is? The vertex, again, is described as the distance from the center to the vertex, which is described as a, So a was already given, or a squared was given as 4. So I know that I take a square root of that. So a equals 2, counted 2. I, plotted those. And now so I plotted C, I plotted A. I need to plot B. And B, again, was given right there. So square root of 25, this was b squared. So in order to get b, I've got to get the square root of that, and that was 5. So I count up 5, 1, 2, 3, 4, 5. At this point, I have enough information to draw my rectangle. So I connect from vertex. So again, I was told that for the hyperbolas, I don't know if I already mentioned this, but the asymptotes that help us draw the hyperbolas, the center will be the connecting point of those two asymptotes. So at this point, I can draw my rectangle, which whereby this distance right here, which will be the length, will be basically from vertex to vertex, and then if that's the length, this has to be my width. And then the width will be basically from the co-vertex to the other co-vertex. So I connect my rectangle, and then I know my center. That allows me to draw my asymptotes. And then I do remember that a vertex is a point on the hyperbola, and the focus is also inside. And that allows me to be able to know how to draw the hyperbola. If you have any questions here, bring them to class. I'd like to see how you solve them and any problems that you had. The next example, we're given that y minus 2 squared over 9 minus x plus 4 squared over 16 equals 1, and we're asked to graph it. Okay, so pause the video, have a try at this, and then let's discuss this in a few minutes. All right, so how I approached it is I asked myself, first of all, where's the center? The center, okay, I already have an equation, and it looks like the center will be at a -2, and then I grab just this 2 from here, -2, 2. So I go ahead and go -2, -2, and 2. I named that center. Okay, so I already know one piece of information. And then the next thing I ask myself is the orientation. Where is this facing? Well, I need to know if it's a horizontal or a vertical hyperbola. So when I go back up here and look, oh, which one was the positive? Which was the positive part? It looks like y has the positive because oh, I need to have put my parenthesis here and squared. I apologize. So I noticed that this was the positive one. So the hyperbola is either on the y-axis or something parallel to the y-axis. So next thing I asked myself, well, that is important because it lets me know where the vertex will be located, where the focus will be located, and more importantly, where the hyperbola will be drawn. And after this, I just go ahead and grab my focus length formula. And at this point, I need this because I need to know where is the focus located and where is the vertex located. So I already have a squared and b squared given to me from the equation. I plugged, and the remember, a describes the distance from the center to the vertex. So if a squared is, again, we never change the location of a or b in the hyperbola. So a is always right here, a squared is always right there, b squared is over here. So if I take a squared equals 9, a has to be 3, and a is the distance from the center to the vertex. So I go 1, 2, 3. I've got one vertex. The other way, 1, 2, 3. I've got my next vertex. And then I also have b, which is my co-vertex distance. In this case, b squared was 16. I took the square root of that and I got 4. So from the center, I'm going to count, write 4 steps, 1, 2, 3, 4 to give me one of the co-vertices, and I count the other way to give me the other co-vertice. Co-vertex? Yeah, not co-vertice. And okay, at this point, I've got enough information to draw my rectangle. So the rectangle, I have the center right there, and it just goes along. It's got to pass through both co-vertices, and it's got to pass through both vertices, and then the center has to be right there. And then at this point, I can just sketch my asymptotes. And then how do I know if I draw my hyperbola either on the right or left or top and bottom? Well, remember, the vertex is a point on the hyperbola, so the hyperbola needs to include those vertex points, and that's how I know how to graph it. If you have any questions, bring them to class, please. And then on to the next example. So we're given some information here, and then we're asked to write the equation of hyperbola. Pause the video and try it on your own. I went ahead and tried it, and this is what I found. So given those points were really crucial, but just the points don't make sense to me unless I actually put them on a graph. So I went ahead and got my graph paper. I put my y-axis, my x-axis. It looks like I have 2 vertices here. So I graph my vertice at 2, 4, that's one of them, and then 2, -2, that's the other. So at this point I have vertices, and then the foci are 2, 6, and 2, -4. 2, 6, that's one of them, and 2, -4, that's another focus. If you can see, I actually wrote the focus, the center. I just like to do it so that I know where everything is located. And then at this point, I'm like, okay, but I still do not know where the center location is. The center location is important because it goes into that HK location. Actually, we need to put values into them when we write the equation, the equation of the hyperbola in standard form. So I go ahead and, you know what? I know that the center is the midpoint between the co-vertices. It's also the center between the vertices. So I was like, okay, let me just use the midpoint formula because I have that point and I need a center